how do we fly these arms? Because I was saying before, how do we fly from the ground or from the crew? I will focus more on crew perspective, but we will see first how we fly the ISS, how we fly SPDM, then a little bit about the Japanese arm and how we train for this. And we will see what are the main interface of these arms. So a few aspects of SSRMS, which is the main actor in this game. So the SSRMS has already been in space for like 15 years. It's a long time that it's already in space. It's less than 2 tons, but 165 tons. It can move something up to 21 tons. It's 17.6 meters long, so it's a big monster. And it has 7 joints, so 7 joints means it has 7 degrees of freedom to be able to move in any direction in crampy area, and so that's why it has 7 joints. It costed about 600 millions to build, and again it's the main contribution of Canada to the ISS program. And you can see that the speed is not much. The usual speed that we are talking about is 2 to 15 centimeters per second, but usually it's more in the order of the lower scale, and this is the speed we are talking about. So this is very slow. The next slide gives you the engineering aspect of the various dimensions. I will not really detail it too much. It's for your record that you can see what we are talking about in terms of size, the overall length being something like 17 meters. All right, on this little video that is happening, I will let Mike Hopkins describe a little bit how the arm is actually flown and how the arm is operated from the inside of the station. And after this little video, then I will continue the presentation.
Okay, hey everyone. Yesterday we had the opportunity to catch the Orbital 1 Cygnus vehicle, also known as C. Gordon Fullerton. And I'm going to take the opportunity today to talk about the controls that we use for the robotic arm. And so we're actually down in the cupola right now, and this is where we control the robotic arm when we go out and we grapple one of these vehicles like the Cygnus vehicle that we did yesterday. And so this is the control station, and what you see over here on my left, this controls the translation of the robotic arm. And then over here we have rotational control. And then this middle computer is where we actually take the robotic arm into the different modes that we do have. And then on our left over here we have a control panel for the various monitors. So what we're doing when we're grappling is I'm watching on this monitor basically a target on the vehicle, and I've got an overlay on it that allows me to line up the robotic arm with that vehicle, and I just drive right in. Now, I wanted to take advantage today, though, because we have a pretty special opportunity here to show you a unique view of the robotic arm. And so if we look out one of the cupola windows here, you can actually see the end effector of the robotic arm. And we don't get a chance to look at this view very often. In fact, today we were doing an inspection on the end effector. And so if you look in the middle, you can see those cables. Those are what we call the snares. And when we go over the pin that's on the vehicle and I pull a trigger, it causes those cables, those snares, to close around that pin. And that's how we grapple onto a vehicle. And actually you can see up above as well, that's the camera that is giving us that view. And that's a pretty unique view for us, and so just wanted to share that with you.
So what you see inside in this picture, we have 2 places where we can fly the arm. So Mike just explained what he sees and how he flew the arm from the cupola. So the cupola workstation, as you see, it's not very large. There are a lot of computers, a lot of items. So that's one place where we can fly the arm from the cupola itself. So the cupola was built mostly for this purpose, to be able to enable robotic operations. But we have a backup working station, a backup robotic workstation, which is the lab in the laboratory. It has been used many years before cupola went up. Cupola went up only in 2010. So until that time, all the robotic was performed into the US lab, and as I already mentioned it, most of the robotic operations for the crew is based on cameras and visual aspects. So the crew did not really need a window to see the arm. The crew has different cameras mounted on the arm or outside of the station, and they routed these cameras into screens. And for that, in the lab, it was okay, because in the lab they have like screens and it was good enough. So if we look at how a workstation looks like from the lab, you have all of these computers available. So you have these three screens in the middle, and then different laptops. The laptop gives you telemetry, gives you your planning of the day, gives you your procedures, etc. The central laptop gives you the system view of your arm itself. So if the arm is a good config, the communication, and etc., the speed, which mode you are. And on the lower left, what you can see is the main box where you have buttons where you select cameras, where you select which joints you want to command, and if you want to zoom with the camera, if you want to pan, tilt, etc., etc. And there's also some emergency buttons in there. So that's the configuration in the lab, and you can see two joysticks in this picture. One being a little bit a square on the left-hand side. This controls the translation of the arm. So you use your two hands when you fly the arm. Is translation as explained by Mike in the cupola, and rotation on the right-hand side. So the right-hand side looks more like a real joystick that you have seen, and this controls the rotation of the arm. So in the cupola, we have the same setup. We have the three screens at the top, and at the bottom we see again the various laptops that we used for this, and the two joysticks that we were talking about. These are not named joystick, it's named hand controllers. So the translation hand controller and the rotation hand controller. On top of that, in the cupola, to complement these three views that you see from the screen, so the screens are showing you cameras that you have selected for robotic operations, you can use the window itself. So you look out of the window if you help for the robotic operations. But again, in many cases, you don't see the arm because it's not in the line of sight of the cupola. So you have to rely on the little screens and the cameras you have. One of the interesting parts, so when a visiting vehicle is coming, for instance here you see the astronaut Bush Wilmore and Samantha Cristoforetti overlooking the approach of Dragon vehicle from the cupola. So they are using also some rangefinder to measure the distance, and they are getting themselves ready to do the final track and capture of this vehicle. But for the time being, everything is running automatically, and so the ground is pre-positioning the arm, and on the other side, from SpaceX side, they are monitoring that the approach of the vehicle is going well. Then the crew is going into the cupola and getting ready, and here you see, for instance, Steve Swanson and Alex Gerst. They are performing a grapple operation of the newly arrived Dragon vehicle. So they were just finished with the completion of the grapple. As you can see on this picture, Steve Swanson in red in the middle is mostly looking at the central screen. So he's not really looking outside through the cupola windows to see what he's doing. He's mostly looking at the control screens that are the main views. So again, in robotic operations on board the station, for the crew, it's mostly based on camera pictures and screens. The ground is of course supporting the crew during this operation. So here you see mission control in Houston, when you have on the left hand side the flight director and on the right hand side the Capcom. The Capcom is the one talking to the crew. And for these operations, when we have a visiting vehicle arriving, usually the Capcom is someone who knows robotics pretty well. So here it's the Canadian astronaut David Saint-Jacques, who was involved in all these robotic operations in Canada, and he's of course supporting the operations. As you can see on the big screens in Houston, that's what the crew sees with the camera, and the people on the ground, they are using the same video feed for their awareness, and they look at this arrival of the vehicle, and then you see that the grapple has been confirmed and the crew has done an excellent job, because you see that the vehicle has been captured by the arm. Now, talking about SPDM, so Dexter. Dexter is smaller, but it's more complex. It has a body, two small arms, and it's only in space for like a bit more actually than 8 years. It's smaller. It's the second main Canadian contribution to the space station program. So it has a set of 2 × 7 joints, so it's highly complex, and it's only flown by the ground. So the crew does not fly SPDM. So you see on this drawing how this robot is actually mounted, one arm right, one arm left, with 2 different hands. and the body in the middle can be attached to the top of the main SSRMS. So something which is interesting is the arrival of SPDM some 7, 8 years ago, enabled the manipulation of smaller objects and smaller interface. And one of the things that the arm was also able to do is not only to maintain the station itself and repair things outside of the station, but it was able to repair itself. And it was able to auto-repair actually faulty cameras. So I said the arm has 4 cameras, and at some point we realized that one of the 4 cameras was malfunctioning. The camera is more or less located on one of the boom of the arm. So what the arm did is the main arm, SSRMS, took SPDM, and SPDM was able to grab that camera, remove the faulty camera, put it somewhere, Temsto outside of the station, then take a new camera that went out of the Japanese airlock, take that new camera and put it in place on itself. So that was a nice feature that you see a robot auto-repairing itself using the help of the crew, because the crew has to slide outside of the station the new camera. And that's what we are going to see in this video on a couple of days operation, where the arm is removing the old cameras, Temstoing it, retrieving the new one, installing it and testing it. So that's the purpose of the video.